Testing, test. Okay, here we are again. I just want to make sure the volume's working. So we're going to work on 29 through 35 now, and it says to use a graphing calculator to graph the function using the given viewing window parameters. Pay no attention to that direction. I don't know why that was given. What we basically want to do is see you graph the function cosine of x minus 2. So for one period. So cosine of x minus 2 has an a value of 1, frequency value of 1, a c value of 0, and a d value of negative 2. So you would go down to, draw your midline, and that would be y equals negative 2. Your starting point, or phase shift, is equal to 0. So you would be starting right here on the midline. The cosine function, because of the amplitude, is going to go up 1 and down 1. And your finishing value, because the frequency is 1, the period is equal to 2 pi. So you would just have your endpoint be at 2 pi, and the cosine function would have the 4 tick marks drawn. It would be 0 pi, this would be pi over 2, and this would be 3 pi over 2. And then you would just draw the cosine following the progression that we gave you in class, where it starts high, then it goes to the midpoint, then down low. And you want to just make sure you have the right type of curvature for the function. So that would be the cosine function. Y equals cosine of x minus 2. The next function, this is y equals 0, is going to be let me just shrink this down. The next function is going to be to graph y equals y equals 4 sine of x minus 6. So the a value on this one is 4. Amplitude is 4. Frequency is 1. The phase angle is negative pi over 6. And there's no d value. The period, because b is equal, the frequency is equal to 1, is going to be 2 pi radians. And the phase shift is equal to negative pi over 6 divided by the b value of 1. So that turns out to be pi over 6. The ending point, remember the ending point is equal to the phase shift plus 1 period. And so you have to do a little bit of work with fractions here. The phase shift is pi over 6 plus 2 pi is going to become, you have to switch this to having a denominator of 6, so that'll be 12 pi over 6. So your ending point will be 13 pi over 6. So now we want to graph it. So I'm going to just draw one period of it. Its midline is 0. Its amplitude goes up 4 and down 4. It's going to start at pi over 6, and it's going to end at 13 pi over 6. And I'm going to do my subdivisions, and then remember that sine starts at the 0 value, goes to its highest, lowest, highest, midline, lowest, and back to the midline, and make sure you include the curvature. It's very important for the sine function. And this would be the graph of number 30. Number 31, if you could follow 32, 31 says just find the amplitude. This is so easy. The amplitude is equal to 2. Remember, it doesn't have to be negative. It just tells you how much from the midline the function moves up and down. And the period for this one, well, you need the b value for the period. The period is going to equal 2 pi over the frequency value of 3. So you're looking for a value of 2 pi over 3. Next one, find the phase shift. The phase shift is found remember what we did in class, phase shift is equal to negative c over b. So all you have to do for this one is make sure you have the negative of negative pi over 4, divide that by 6. So now this, you'll have pi over 4 divided by 6. Make sure to multiply by the reciprocal, and you end up getting pi over 24. And hopefully we have an answer. And notice it says pi over 24 to the left and pi over 24 to the right. Well, because this is positive, it would be pi over 24 to the right. So don't fall into that trap. The next one is, can you identify from the graph the function? So we need to draw our midline. And on a multiple choice test, you want to try to identify or eliminate some choices. So notice this one, that is a phase angle, so that's not it. This is a downward midline shift down to, so that's not it. This one here has no midline. Well, midline is at 0. They all have a midline. And part D would have the midline of 2. So this one is the only possible answer. And now we're moving on to when we were working with trig identities and simplifying trig expressions. When we want to simplify this, remember it says to multiply and simplify. So we first multiply. So you're going to distribute the secant through. We're going to then use our identities. Remember, you need to have your note card with the 11 identities. I'm going to pause it, I'll write it, and then I'll start the video up again so you can see those 11 identities. Okay, I'm back, and I wrote the identities right here on the side. So you see the reciprocal, the quotient, and the Pythagorean. If you need to write them down, pause the video so you can jot them down on your note card. Now what we want to do is, once we multiply in 35 the secant through, we want to look for things that cancel out. So I'm going to rewrite my everything in terms of sines and cosines. And here I used a reciprocal identity. Here I used a quotient identity. Here I'm going to rewrite that as a reciprocal identity. And this is just the sine of x. So in simplifying this part, the cosines cancel, and I have 1 over the sine of x, plus this part becomes the tangent of x, because you get sine over cosine. So now I'm looking for answers that have tangent of x and 1 over sine of x, and this is the closest because this can be the cosecant of x plus tan of x. I hope this helped you. I'm going to next upload a video for the next set of questions, so tune in if you need help with those.